All right, we're back with the second installment of these videos, and we're going to talk about interpreting and extrema and end behavior. So interpreting a graph also involves estimating and interpreting where the function is increasing, decreasing, that's going up and going down, positive and negative, that's like above the x-axis or below the x-axis, and where the function has any extreme values. That would be either high points or low points, it's peaks or valleys. Okay, so let's look at this table here, and it describes a whole bunch of things about this same graph. If we're talking about positive or negative, we're talking about where the graph lies above the x-axis and below. Notice in blue here and right here, the graph is positive because the y values of that function lie above the x-axis, therefore the graph is positive there. In the red sections, the graph lies below the x-axis, therefore the y values would be negative, and so we say that the function is negative there. That's different than increasing and decreasing. Increasing and decreasing, remember, you always read a graph from left to right, okay? So increasing is where the graph is going up as you move your pencil from left to right, and decreasing is where the graph is going down from left to right. This is not the same thing as positive and negative. So notice this red portion here, the graph goes down until it bottoms out, and then it turns and goes back up. Now, so it's decreasing there until it starts to go back up, then it's increasing until it starts to go back down, and it's decreasing, all right? Now, extrema are just extreme points. Now, when you think extreme points, you're thinking of a peak or a valley. Anytime there's a peak or a valley, that's an extrema, all right? Now, minimums and maximums are just identifying what type of extrema. If it's a relative minimum, it's a low point or a valley, and a relative maximum would be a high point or a peak. Now, the reason they call them relative maxes and relative mins is because they might not be the actual highest point on the whole graph. Like this relative maximum right here is a peak, but it's not the highest point because the graph continues to go up over here, okay? So that relative to the points around it, it's a high point. Okay, so point A is a relative minimum since no other nearby point has a smaller or a lesser y coordinate, it's a valley. Point B is a relative maximum because no other nearby point around it has a greater y coordinate, it's a high point. All right, now last thing is what we call end behavior. The end behavior describes the values of a function at the positive and negative extremes in its domain. So what you want to do is think about, as you continue to go out on the x-axis, as you continue to draw the graph, like this arrow is pointing downward and to the right. So what that means is as you move to the right, the graph goes down. In other words, as x increases, when you move to the right on a graph, that's talking about x increasing. And as you move down, that's talking about y decreasing. So as you move to the right, as x increases, y decreases. Conversely, as you move to the left, and that means in the negative direction on the x-axis, in this graph, the graph is pointing upward and to the left. So that means that the graph, as the graph moves to the left, the graph goes up, or as x decreases, y increases. Now, when we're talking about the end behavior of the graph, you want to phrase your answers with that type of language. Now, it might not be word for word the same. It might be as x increases, y also increases, or as you move to the right on the graph goes up, okay? So you just have to look at the graph. So here's one for us to take a peek at. The US retail sales of video games from 2000 to 2009 can be modeled by the function graphed at the right. Estimate and interpret where the function is positive, negative, increasing, decreasing, the x-coordinate of any relative extrema, and the end behavior of the graph. All right, so let's first talk about positive and negative. It's positive from right here to right here. So you just look on the x-axis, where is this? This is at about negative 0.6, and this is at about a little bit past 10, not quite halfway between 10 and 11, so we're going to go 10.4. So the graph is positive between negative 0.6 and 10.4, and it's negative for x values before negative 0.6, so x is less than negative 0.6, and values after 10.4, so x is greater than 10.4, the graph is going to be negative, right? Now we got to look where it's increasing and decreasing. So, well, first let's interpret it. That means that there were positive sales between 2000 and 2010, but the model predicts negative sales after 2010, indicating the unlikely collapse of industry. Now, this last piece of this sentence, I wouldn't expect you to say something like that. Just interpret what the graph actually shows. All right, so it's increasing from for values less than 1.5. So you can see like right here, the graph goes up until about this point, and then it dips down a little bit. And then it dips down till about right here and turns and goes back up. And then it goes up to about right here and dips back down. Okay, so now we're slicing the graph up according to where it's increasing or decreasing. So it's increasing for values before 1.5, so it's increasing for x less than 1.5. And then between, oops, I put that line in the wrong spot. Between about 3 and 8, it's increasing here, okay? Now remember, whenever you're indicating where a function is positive and negative, increasing and decreasing, you're talking about the distances on the x-axis for where the graph is going up and down or is positive and negative. Now it's decreasing right on this little piece right here, so between x equals 2, about 1.5 and 3, or 2 and 3. I'm going to make that 1.5. And for x values greater than 8, it's also decreasing. Now let's talk about what that means. That means that the sales increased from 2000 to 2002, then decreased from about 2002 to 2003, then from 2003 to 8, the sales increased again, and then after 2008, the sales have been decreasing. Now, relative maximums, there's a maximum at about 1.5 because that's where the graph changes from going up to going down, and at 8, the same thing happens. And then a relative minimum at about x equals 3, that's where the graph changes from going down to going up. So you can see all the characteristics here. It's increasing on the blue parts, decreasing on the red parts, and you have a relative max where it changes from increasing to decreasing here and as well as here, and changes from decreasing to increasing here. So the end behavior. Now, as x increases, as you go out on the x-axis, the graph continues to fall. So as x increases, the value of y decreases. And same thing as you go out to the left. So that's why we put it all in one statement. As x increases or decreases, the value of y decreases. So as you move to the left or right, the graph goes down. Right here, okay? So the end behavior of the graph indicates that sales several years prior to 2000 and several years after 2009, or negative sales rather, which is unlikely. The graph appears to only model sales between 2000 and 2009, and only can be used to predict sales in 2010. And the reason for that is in the context of sales, like you can't sell negative dollar amounts. You could sell nothing, but you can't sell negative amounts. So the graph really only makes sense for the positive values there. Okie dokie. All right, so in this one, we want to estimate and interpret where the function here is positive, negative, increasing, decreasing, the x-coordinate of any relative extrema and the end behavior of the graph. Go ahead and pause the video and hit play when you're ready. All right, so here it's positive for x greater than 1, and it's negative for x less than 1. So what does that mean in the context of the problem? That means before 1 hour, the the temperature of the object was negative, and then after 1 hour, the temperature of the object was positive. So it's increasing all the time. So for all x values. What does that mean? That means that when they took the object out and set it out to thaw, the temperature of the object was continuously increasing, right? So there are no relative extrema in this function because there are no high points or low points. The end behavior of the graph. So as x increases, y increases. As x decreases, y decreases. Another way to say that, as you move to the right on the graph goes up, and as you move to the left on the graph goes down. Now, I will say in the context of this problem, it doesn't make sense for you to use negative values of time because time can't be negative. At 0 hours, that's probably when they set the object out to thaw. And then from that point forward, as time moved on, the temperature of the object steadily increased. Okay? All right, guys, that's it for this section. Please continue on to your assignment. And as always, reach out if you have any questions. Take